high above New Zealand's rugged North Island terrain lies Dome Valley. A landscape of steep hillsides, dense vegetation, and challenging access. Beautiful to look at, difficult to build in. For decades, projects like these have forced utilities to work with the limitations of geography. Heavy materials, difficult logistics, complex installations. But here, something different is happening. Because sometimes innovation is not about building bigger structures. Sometimes it is about building lighter ones. In remote construction, access is often the greatest challenge. Many of these sites are inaccessible to cranes, trucks, and conventional equipment. Some are walk-in only. Every tool, every component, every decision becomes more difficult when the terrain refuses to cooperate. Traditionally, infrastructure in environments like this has relied on concrete and timber, proven materials, but heavy ones. And in Dome Valley, weight changes everything. The structures being replaced had stood here for around 40 years. Even removing them proved challenging. The old concrete poles were too heavy to lift out whole. Crews were forced to cut them apart before helicopters could remove them safely. A reminder that decisions made decades earlier continue shaping maintenance challenges long into the future. So the project team took a different approach. These are Fibre Reinforced Polymer utility poles, paired with composite cross-arms, together forming what is believed to be the first fully composite H-frame configuration of its kind across Australia and New Zealand. But the real story here is not simply the material, it is what the material makes possible. A fully assembled H-frame, 2 poles, cross-arms, hardware, insulators, all weighing less than 1,200 kilograms. Light enough to be flown into position in a single lift. Not piece by piece, not component by component, an entire structure, suspended beneath a helicopter, moving through the valley with remarkable simplicity. For crews on the ground, this changes everything, because much of the work no longer happens high above the earth. It happens safely at ground level. Components arrive pre-drilled. Structures are assembled in controlled laydown areas, then flown directly into place. Less work at height, less time exposed to risk, fewer moving parts, and fewer opportunities for things to go wrong. Remote construction has always demanded compromise. Compromise between access and efficiency, between safety and productivity, between cost and practicality. But projects like this begin to challenge those compromises, because lighter infrastructure does more than reduce weight. It changes methodology, it changes logistics, and perhaps most importantly, it changes expectations. These structures are designed for 80 years of service, resistant to corrosion, resistant to rot, resistant to environmental degradation, and in places where every maintenance visit may require helicopters, specialist crews, and difficult access, longevity matters, because the most efficient maintenance task is often the one you never need to perform. Across Australia and New Zealand, utilities face increasing pressure. Aging networks, remote infrastructure, more extreme weather, higher safety expectations. Projects like Dome Valley offer a glimpse at another way forward, a future where infrastructure is not simply stronger, but smarter. Only 13 H-frame structures were installed here, yet their significance stretches far beyond the number. Because in these hills of northern New Zealand, a quiet shift is taking place, and sometimes the future arrives not with heavier machinery, but with lighter infrastructure.